Hello, I think we are live. Good stuff. How is everyone doing? Welcome back to another episode of working on a new documentation system as a replacement for Doxygen. Primarily for WhiteBox, but at least some of it will probably be made publicly available if it's any good. Now, just as a quick reminder of what we're working on here. This is the rough pipeline that Doxygen goes through. We have some code. Doxygen takes that in, possibly using clang, but possibly using their custom parser. Then they generate some XML, and then that gets turned into HTML. So this XML describes the structure of the documentation and the bits of code that it's attached to. Now you can kind of intercept in this stage, just take the XML and turn it in, use some other tool to turn it into HTML or PDF. I'm mostly focusing on HTML for the moment. Other ones are kind of, I'm not sure it makes much difference, to be honest. All the same points apply. Now, I'm not particularly happy with any of these stages. The syntax that you have to use in your code isn't great. As soon as you want anything sort of vaguely marked up, it becomes almost illegible in the code itself, and that's where your developers are actually using it. So you probably want that to be pretty good, even if the output is nice as well. Doxygen itself, fairly slow. Also only works on the entire code base at once. Well, I mean, I think you can do some tricks to split it up into a hierarchy of separate doxy files or whatever it is, but you can't do incremental builds. Just based on files, as you would with Ninja and with normal compiles. XML, what more has to be said? It's XML. Who wants to use that format? And then the HTML generation is subpar, let's say. Now other tools kind of fit in here, but they're based on the rest of the pipeline, and not particularly happy with that. So my idea to work on this basically came when I realized that Clang has a way, I think initially because of Doxygen, like making it so that it can check that your doc comments match up, say the described parameters match up with the actual parameters in the function. So Clang has a way of representing your Doxygen comments as part of its AST. So that means we can, and because Clang can dump the AST and it can dump it in a JSON format, we can dump any files we want from Clang. We can look at that JSON. We can turn that into a more useful format, stripping out all the extra cruft that we don't want. Leave that in a kind of a simplified JSON. I've put that as a separate step because I think it's useful just to have, this is the documentation and these are the things that it's attached to, as separate from everything in the AST. And then, you know, that's a file. You can split this up in various ways. So this is what Clang is doing, going from source to internal AST representation to JSON, and then our current thing we're working on is turning this JSON into a simplified form of the JSON, and then you can go from that simplified form of JSON, do whatever you want, turn it into HTML and profit. Yeah, so there are a bunch of other tools like MakeDocs or I don't know, that's one that comes to mind. And let's say if you've written your this tool doesn't need to know what format you've written your doc comments in. It just needs to know that they're there, basically. So at least that's the ideal. We'll see whether that ends up being completely possible. Yeah, so if you've written them in Markdown, then you can use, something like mkdocs and basically just have this output almost verbatim from the JSON to an extra Markdown file, maybe with just a little bit of extra, let's turn the function and the parameters into a mini code block to put in the Markdown there. And then otherwise you just have Markdown documents that you plug into the rest of your Markdown pipeline. Equivalently, you could use ASCII doc, or you could even have, you could describe your comments using some structured format like JSON or MetaDesk, which I kind of want to explore, MetaDesk, and then turn that into the HTML. Yeah, so we're continuing our work on this JSON conversion, and last time we got pretty far actually. If I can bring up this, let's have a look. Nope, apparently. Why does that not want to come up? There we go. Okay, so let's have a look. If we go to experiment/run, it's just a batch file with some stuff attached to it. Did I leave it in a broken state? I might have. Okay. So just before I broke it last time, the state was that it would take in. I will just set the font size to be a bit more legible. Let's open up experiment / clang ASCII-JSON, and let's have a look at experiment / test.c.ast.json. So this is the format that clang emits, and let's see what we get. These comment markers. Let's bring open the file that we're operating on, experiment / test.c. So this is just a simple file. It only works on the doc-like comments. It doesn't work on a regular comment. So the triple slash or the / bang or the / double star type comment. And then also you can do end of line doc comments with the a left arrow at the end of those. So those get captured by clang, and so the key thing that we're actually using here is this the offset into the file, and then we're just taking it from the file. But it also actually does capture some of the text. I was going to use this, but it doesn't capture all of the text in the case where we have Doxygen-like things that it's passed in. So it's just easier to take the full comment basically and strip out the initial lines. Yeah, so let's have a look at why that's broken. While I do, I'll just open up my mod view and say hi to anyone who's there. So who's who have we got in chat? I realized that it's out of hours for our American friends currently. So yeah, sticking with Europe, I imagine. Now, I still haven't quite worked out everyone who's a bot. We've got Agilet and Alien Gathering, another TTV viewer, Lizzie Beth, and Mark Z, many underscores. Now I think I'm actually not sure how many of those are bots. Oh well, that's okay. Do say hi if you're a real human. Right, and we've got some coffee going on here. Not normally, I try not to drink coffee regularly, but when I'm streaming and haven't had enough sleep, then perfect opportunity to. Most important thing is not to have coffee more than 3 days in a row, because otherwise you get desensitized to it. And you have to have more to be at your initial level. Okay, so yeah, we also have enough information to recreate a bunch of useful things. Yeah, I guess so. The only thing that makes me hesitant with regards to just putting out comments directly is referencing other things. Now, actually, I'm not sure that you win anything despite that. Yeah, I think that's going to be possibly the hardest bit though. So if I wanted to link to Vim doesn't auto continue with the 3 slashes. References data. Let's just put that in this format and see whether see what it looks like in the AST. Yeah. So we've got inline command comment ref args data. Okay, so it's not actually doing any it's not actually finding us the ID of the data thing, which is the real crux of linking stuff. So we're not actually losing any information by just turning that into a plain text comment. Cool. Right, so let's open Remedy BG. If you're not familiar with this, you should be. It's a sorry, make the font a little bit bigger. Yeah, a debugger written by George Manhorn, one guy by himself in his spare time, and it competes in many ways with Visual Studio. It doesn't do everything that Visual Studio does, but it does some things that Visual Studio doesn't, and it's much faster. I will use both depending on what I need at the time, but if I have the option, I will prefer to use Remedy. Oh yeah. Cool. So yeah, we can see that we're crashing here. Now I think so far I haven't used anything that's actually platform specific. So it should probably work on both Linux and Windows. The only thing I was thinking is just that it's kind of silly that this crashes silently, and you can add basically crash handlers on both either Linux or Windows, but they're a platform specific thing. Okie doke. Let's move our disassembly down. We don't really need that at the moment. So we're looking at the string from source range, and the file is empty, right? So let's see, we probably string.c.ast.json. Yeah, that's not the one we actually want to look at anymore, is it? Test.c.ast.json. Let's just see whether that runs. Print node range. Right, so I think we're just trying to print a node that hasn't really been initialized, or maybe the one that's this might be the root node. In fact, given that this function recurses and there's only one of them, it looks like it must be the root node. So let's have a look. Do we actually... Let's find our node. Now, I mean, one thing we can do just as to prevent crashing is to make this safer. We'll start with an empty string. We'll only set that if range.file. Is it range is valid? Source range. Alright, let's just add a source range is valid. Range. Source range is valid. Just keep this option of changing back to the previous thing. Okay, so that's one level of avoiding crashing, but not necessarily doing the right thing. Yeah, so it's it looks like it's exiting, but it's not doing anything useful. We call this print node once. bang node has printed. Print node. Once. All right, so if source range is valid, node range and do we need a name? Not for the moment. Let's add that later. Okay, great. Okay. So what are we printing here exactly? That looks like more than I'd expect. Oh, we're probably printing the range of the entire file as the as one of these nodes. Okay, so we can, fortunately, I think one of the nice things about LLVM is that they're quite schematized. So I'm pretty sure that everything ends in decal. Parm var decal. Interesting having a mix of parm and param, so maybe not quite that schematized. Yeah, so I mean, there's this kind of thing, so you can. So we could, oh yeah, we could actually use this for finding out other functions that are called, I think. Let's see about that. Yeah, so we reference this decal inside here. So in our output format, we can have references or referenced by. And the way that I've normally done that kind of thing, it's kind of like a subscriber model where you just have a... I'm not going to do it exactly now. And you just have around destination, no, sorry, source and destination. And then you have the idea is kind of to do something like somewhat database like. This is kind of an index into a database. So you basically having, if you imagine your database, you have your database of when you have many to many connections, then well, first of all, if you have one to many connections, then on the many side of that, they can reference back to the one. And if you have many to one, then vice versa. But if you have many to many, and where in a database you can't have arrays attached to each thing, then you need a separate table of to and from relationships. And this is kind of basically what that's doing. Possibly not the clearest explanation. Let's quickly diagram that out. So you have a few here, a few things here. Now you might be in a situation where you have one-to-one. That's pretty simple. Either of these or both of these could store the reference, right? Let's call it A, B, C, 1, 2, 3. So this could be storing 1. This could be storing 3. This could be storing 2, right? Now, if you have one to many, i.e. that can do that, and that might be just doing 1, and then that one's doing 1 and 3. In this case, then this can't store both of those, but the recipient could store C. And sorry, I've already yeah. So sorry, this is actually a one to many, isn't it? Or many. This is already many to many. If you had it so that that was going to there, and that one just didn't go to anything, then this way you could store B, A, and A. So then if we go back to the previous example where we have many to many, we can no longer store just one thing. So instead we store these edges as a separate data structure. And so we have A1, A2, B3, C2, C3. And then you might want to attach these because it's useful to know what all the A's are, and you'll attach these because it's useful to go through the twos, and attach these because it's useful to go through the threes. So yeah, so if you're on 3, you can look at all of the things that are attached to 3. If you're on A, you can look at all the things that are attached to A, and so on and so on. Now, in this case, both the source and the destination are of the same type. So makes things slightly simpler in terms of the data structures required. So you'd then have a reference sub next source, next dest, making sure that you have all of the asterisks in the right place to make pointers. Now, actually, you need to be quite careful here. Do you mean next by source or next source? I.e., is the source staying the same and you're looking for the next destination? Or is the so like next source and next by source? If you're doing next by source, then you assume the source is staying the same and you're iterating destinations. And if you're looking at next source, that implies that the actual source changes. I think I probably prefer to do next by. Although that may change. So we'll come back to that, but it's just sketching out the idea. Back to the actual problem at hand. We're trying to print all of the useful information. So let's see. This is actually not quite true, right? Because this is only true if it's a comment node. So if node kind is equal to or I can actually make it a slightly quicker check. Node has suffix equal to comment, then we'll do the comment, and then otherwise we'll do other things. Right, yeah, that has to be later. And so this is an advantage of doing type def struct node, the contents of node, and then type def, like giving the actual structure name as well as just the type def of that struct, which I realize is not particularly clear, but that's C for you. Let's look at another example. Yeah, so here you can see that we give the struct a tag name, and then we type, if you were to use that normally, you then use it as struct source range, whatever. So we type def that to just source range so we can use it more simply. But you can also do this, and you could use it with just source range as like an anonymous struct that's then been type def to source range. But the advantage of having it in both places is that you can forward declare it with this this type of construct. I mean, you could even do. Oops. you could do this again, and then you can be entirely unaware that it's going to be forward declared, and then just do this by default, basically. Which is what I do currently with my arena allocator in the normal code, because I realized that I needed to be able to declare it from elsewhere. And that works particularly well when you're only using pointers to types, as opposed to well, pointers to the value, as opposed to the actual passing the full struct through a parameter. Because if you're passing a full struct, then the compiler needs to know how big that's going to be and what data is involved and so on. Whereas if you're passing a pointer to it, it knows that it's just a register size integer, basically. Okay, so we're back to just printing out all of our let me get my mouse back after using the graphics tablet there. So yeah, we're back to printing out just the comments. The indentation here is based on the indentation in the structure here, the node structure here, which yeah, will become more apparent once we're back to printing the names of stuff. So first of all, let's have a look why we're not printing names. No, nothing has got a name here. Let's run this. Right, node name 0, type def decal. Okay, so we could not print the node until it has a name. Does it have a kind? Sorry, of course it does. I just literally looked at that. Yeah, so we want either a name or... Yeah, okay. It's probably easiest to do that on this side. Let's make a little bit flag thing. Rather than loads of these bools, because then we can do a single check. So we're going to describe this as node range, node name, node kind, node and then we'll just shift a 1 by the index here. So if you're not familiar with what that looks like, then in binary, that'll be like this. So they don't overlap at all. And so we can have a number with multiple of these one set, and we can tell all of the things that have been set from a single number rather than loads of different booleans. I'm not going to keep those because I'm happy with how that works. Right, do we need anything else? We need good ID. Let's do this in the order that they tend to get set in. So, so ID and then kind and then range. else do I care about? None of these for the moment. I'm actually going to get rid of this. Yeah, so I think currently we want only the comments and the decals to print. But we will later want to recurse into compound statements to determine node ref. Okay. So let's just make a note. Note this. We repeat the call here because we want to print in prefix order. Equals 1 shift 0. Okay, 2, 3. Just to make it clear. Right, so we start with 0. We could do things like add is comment into either this enum or a separate enum. But I don't know, it seems like we're probably fine using text for the moment. Partly because we don't know exactly how many things we want to handle so far. Should recurse. Should print. So yeah, there's other things that we has. So rather than setting has name equals true, we're going to set has to or equal, i.e. to add another bit or make sure that a particular bit is turned on. And we're just gonna, has or equal node name. So if this is sorry, not binary 1000, so that's moved over by 3. If you have a 0, then this makes sure that this is 1, and if it's already 1, it stays 1 when you're ORing. Hello, Skytrias. I'm sorry I haven't looked at my comments in quite a while. How you doing? Yeah, so you can do or equal node range multiplied by that. So it's either something times 1 or something times 0, which means it's either 0 or itself. Now you only want to do this with Boolean. If you don't know that this is a Boolean already, you can add bang bang in front of it, which will convert it to true or false, and then the first one will inverts it. So if this is true, if this is anything non-zero, it becomes false, and then the false gets inverted to true, which is always 1. But this is already a Boolean, which based on the type system is going to get enforced to be 0 or 1. And you can have a look at Godbolt if you can see that the code generated actually enforces it to be 1. So unless you're doing some like accessing memory with a type that's bool, doing some special casting stuff, then regular values will always be enforced to be 0 or 1. And I know that I'm not doing any memory tricks here, so I'm happy to rely on that. So has underscore. And then what we can do is inside this enum, we can do node is printable, and we can set that to ORing a bunch of different things already. So actually, this may mean that adding comments in decals is worthwhile. So we can say node ID, or we want all of these things. We must have an ID. We must have a kind. Actually, I don't think the ID is. I'll keep it in for a moment. I think they all have an ID, so that shouldn't be a problem. We must have a range. I don't think we ever don't have a range. And we and then we can do slightly weird things like node is comment or decal, or maybe just has printable content. Node print. That's too close. Node is ready to print. Decal or comment. Or node printable. note that if we did this directly as encoded it as print as a decal or a comment, then we can't do this with a single thing. With a single check. Okay. And then maybe this should be added to the as a tag. Now you want to be slightly careful when using this. There's a few different things you might want to do with it, and you gotta be careful to pick the right one. Do I want to keep this as a It's kind of handy to be able to just do all the checks in here, so I will. I'll just pass it in as a call that node flags. We'll pass in node flags. Node flags equals 0. Are you trying to iterate the JSON file only once? Yeah, ideally. But fortunately we get all the information in the right order, so that seems to be possible. Because with previous stuff I've done on with JSON, I'll have like a convenience function where it'll like, you have your object and then you can search through the object for a particular key. So like the first time you'd search for ID, and then the next time you'd search for kind, and you'd go start ID, iterate to kind, then you'd go for range, and you go ID, kind, lock, range. So you end up going through the entire thing multiple times. But it's been LVM prints it in an order where we can just do a single pass through. As far as I can tell currently. We're not using this. Flags equals 0. Wherever I've got has flags. So is comment or is compound. We're not using that elsewhere, so let's restrict its scope. Is decal if it has a prefix, sorry, a suffix of decal, function decal, we want to check that what we don't want to check, we just want to directly put into the flags whether or not it's printable. So we're going to do flags node printable times is comment times is decal. And I'm going to make that an and. It's kind of the same operation really, but and is more explicit. You could also do double and, but we know that these are booleans, so there should be 0 or 1. This is just a bit more, it conveys intent a bit more. I can't use and here because it's not 0 or 1, it's somewhere else in the you know, the bit may be higher than the first bit, whereas the bit is definitely the first bit. Okay, so let's see. Node has printed. If flags, yeah, so this is where we're going to be careful. We want to check, so that there's different things you could check. You could check, are all of these things set? You could check, are any of these things set? Or do the flags match exactly this? That is to say, no more and no less. So if we could do flags equals node ready to print. So that's exactly that. We could do flags and node ready to print equals node ready to print. And so that means we have nothing less than those set, but we might have some other things set as well. We could do flags and node ready to print just as a thing by itself. So that means if any of them are set, then this evaluates to true. And now the question is, which do we want? Now I think we want this one. I think we want to check, make sure that all of these are set, but other things can be set as well. Yeah, that's probably right. At least for the moment. Let's just add another set of parens, just to be super explicit. Make it look like Lisp. And note that because we've bundled all of these into a single integer, so not only is it taking up less space, i.e. 1 bit per boolean, rather than 1 byte per boolean, but it's also much faster. It requires fewer operations to check whether it's in the state that we want. I mean, I guess if you had, by default, this will actually take up, this will, as it's an enum, in C it'll be 4 bytes, it'll be an integer. So this is actually, we're only really saving 1 byte, but you could have up to 32 if you're doing it this way. We could also use these and rather than do it directly, just treat it as a single uint type thing, and then still continue to use the flags. And in that case, you're using 1 byte to capture update flags. Anyway, let's see whether that's working. Cool. 610. Print node once. Flags. I think we might actually be able to do it just here, because we should hit this, like if we're going down here, as soon as all the things are ready, we should hit this before we hit inner. Because if it, if type was the last thing we wanted, then we'll have finished type, we'll check this, and then we'll call into it, and only then will we hit inner. So I think we can probably be able to get rid of this. It's always nice to simplify these things. Only have one call. Right, so that's that looks like that's crashing at some point, or it's just never running. It's never triggering. Okay, because we're not setting the things, which would explain why we're not passing that if condition. So if it's kind, then we're going to set we definitely want node kind, and then we'll OR that with this potential one. Actually, I'll just do that as two separate things, just to make that super clear. Node kind. Flags or equals node name. Flags or equals node ID. Great. I always forget to turn that off. Let's see. Flags ID set. Does Remedy really not have enum tag? Okay. So the thing that we're looking for is node is ready to print. Did I just call it node ready to print? Okay. '23. So we're looking for that. Right, so we want to check that we're not hitting inner before we hit the other things. Right, flags, binary. So we're missing the third one. What's the third one? Name. But we're not asking for names, so that's fine. Flags and node printable. Kind. Decal. Okay, so it should be printable. Ha. Yeah, okay, so that's my mistake. I don't want it to be a comment and a decal because that never happens. I want it to be a comment or a decal. Okie dokie. Now, maybe I can't entirely use flags so much, because if it is a decal, then we want to wait until we have a name, really, don't we? Okay. Alright. Fine. Internal inline. Node is ready. Ready to print. Node flags. Term flags and alright, let's make this comment decal. The comment being ready means is that collection and decal ready is node decal or node name. We need all of those. So flags and node comment ready equals node comment ready or let's just replace comment with decal. Let's also wrap those in parentheses because bitwise stuff is always not quite what you expect in terms of precedence. I'll let the compiler decide what type of OR it wants to choose there. Node is ready to print flags. Okay. Right. Let's see. Node printable. Node. Yeah. So we no longer need that. Flags or equals node comment times that, and then the same here. decal, and then we've definitely hit node kind, and then we can check is compound, or if you're just checking a single bit, you don't have to be quite as careful. You can just check whether that bit is on. Because you can't have a state where only part of it's correct. Okie dokie. Right, so name integer, name single. Let's how do you want to do this? So let's find record decal, one they're actually using. Tag used. Yeah, okay. So that's whether it's a structure or class, presumably, or a union. Let's just add a union as another option. Yeah, cool. Yeah. So we're probably going to want to keep that. Tag used, and then what's the equivalent for function? Is there an equivalent for function? We have the name, we have the mangled name. Okay. All right, I'm going to be back in just a sec. One moment, let's just quickly update this. And we are back. Hello again. Just done the most important thing of getting myself some tea. And I've just noticed that my countdown is being added somewhere I don't really want it to be. One moment. Let's remove that. There we go. Cool. Minor glitch aside, how's everyone doing? Hopefully you've all had a bit of a break to get something to drink, move around a bit. Let's see. Let's see. Now I'm not 100% sure what we're going to want to do with the types, because the clang system's a little bit complicated, but maybe it has to be. I think the qual type is normally the most important of these. Let's see. So when we're looking at tag used, sorry, in complete definition true. So we have the record decal for that. Do we also have? All right, let's do my standard thing of that and just see how that looks differently in the AST. Okay, so we have elaborated type, struct data, we have owned tag decal, data, and then we have qual type struct data. Okay. What makes it owned as the tag decal? In a the inner is a record type as opposed to a record decal, and this is the actual version of that decal. Okay, is that going to change anything really? I don't think so. So we have type of tackle data. Let's rename that differently, just so we can distinguish them. And this is where you run up against the limitations of JSON as a format, in that, well, you basically have to invent your own ID system for referencing, as it's a tree, not a DAG or a general graph. But again, this is probably where our references referenced by Notion is going to come into play. For functions, that'll be calls. For types, that'll be where it's a member and where it's type def, whatever. I think that'll be fine. Decal kind record decal name data. Yeah, it's weird that that's the inner. It's also weird that we have these like multiple. So we have a type def, and then inside that type def we have to look further in for more nodes, more information, twice. What's the thing we really want? I think it's well, we have owned tag decal here. Now what makes it owned? If we do type def struct data my data2, how does that come across? Is that going to be consistently owned tag? My data2 dsugar quell type. It's no longer owned, is it? Okay. I think it's inner and then decal are the real things we're looking for. Right, let's just make a note of that, although we won't handle it right this second. That does mean that we can't print until we have actually gone through inner. But that's just going to be another option on the flag. So that's actually all right. That's fine. now that we only have this in one place, are we using the flags anywhere else than that? No. Let's move the flags out of here. Node is ready to print flags. I think we'll leave that in a separate function for the moment. Just simplify that a little bit. Okay. Okay, so we're going down. We see a type diff decal. We then look at the inner data for that. We see an elaborated type. Sorry, got a sneeze. Yes, we've seen an elaborated type, and then we have to look at the inner again for that. And we see that it's a we can then get this actual information that we want of what we're type diffing to. So I'm kind of constantly battling the tension in my head of I want to simplify this as much as possible, but it's also possible that LLVM is aware of some things that I'm not, about how type should be structured, and so I don't want to overly simplify. The other side of that is I don't need all of the purposes that LLVM does, so I don't know whether to quite how much to simplify. Like, what is this extra level getting, this elaborated type, as opposed to just the idea of the thing we're type diffing to? I suppose let's compare with an integer. Let's look at our integer type. Integer. Type def decal. Might need to do come on, where are you? Name. Okay. Right, so here we have a built-in type as opposed to. Okay. And then if we do make that another one removed, special int. How does that look? Special int inner of this ID kind type def type as opposed to elaborated type. Okay. And then yeah, that's gonna look. So it looked basically like the. Okay, so you actually get the entire chain in inners here. Interesting. So the question is, for the output format that we're creating, do we want... So they have obviously very explicitly gone for this very consistent AST node structure, where you always get inner as opposed to references or defined by whatever. Do we want to keep that homogeneous structure? Homogeneous, whatever. Or do we want to specialize a bit more? I think we want to specialize a bit more. It's maybe a decision I come to regret. So I think what we'll probably do is defined as, and then that will be either a string, which would be a basic type, primitive type, or defined as a structure with an ID and a name. And then you can, like, I don't like how much of this is repeated, because we don't need to know here that it's that it's a type def decal, do we? Because if we go to it, which takes long enough as it is, then we can see that it's a type def decal. Name. Alright, so here we have special int. You can look at the type information. Right, but we don't consistently get this, do we? This type alias decal ID for, or do we? Do we? I don't know if we do. Let's add a specify like const and see whether we get the same thing. Yeah, and this, so these both reference the underlying integer, not the qualified integer. Okay. And the actual qualified type only gets referenced in this place. Qualify as const, yeah. What if we add another volatile? Does that become an array of qualifiers? Oh no, it's still longer string. Okay, that's kind of rubbish. Okay. Now I don't want to impose too much on the type system. Sorry, I know I'm taking a long time to just kind of talk this through, but I'm pretty sure whatever I end up doing here is going to be, it's going to have knock-on ramifications. Right, let's just make a new thing. Sorry. And what would we like as our output? Let's do the output code first. Set file type equals JSON. So we want JSON 5, will you understand that? So on our ID, we want our kind. We don't want the location, we just want the range. It's quite nice having an offset. I don't think token length does anything for us at the moment. That's inclusive. Forward mode equals syntax. We want the name. Cool. Now, I think we just want like an so it's either one of those two. Or I could give primitive types an ID as well, and then it's consistent. Yeah, I think that's probably a good way of doing it, and I'm pretty sure because these are pointers, if we use the first, 0, 1, 2, 3, at least the first page is going to be unused for IDs. So that means we have at least 4,096 possible things we can do. Integer, like we don't have that many primitive types, so that would be easy. And probably reserve 0. Yeah, let's do that. Okay, so we'll have an ID. Null x 1, 2, 3, 4. Qualifiers, and that'll always be an array. It might be empty. I think that's the trick. Is basically just do super simple structure. It's very enforced. Basically make we're doing C structs, but we're doing them in JSON, right? So it's always exactly the same. The difference being that arrays are as long as you want them to be. So qualifiers might be empty, or it might have const volatile. pointer? How does that work in here? Right, so let's just do it for this particular thing. Let's not repeat ourselves. Elaborated type, owned tag decal. This is what we want in this particular case. We don't need to capture the name. Right, so what does the pointer look like? So one option is to do what Dwarf does and have basically type def is the same as any other qualifier, as is a pointer, and they just become an extra step in the well, that doesn't quite work, does it? They become an extra step in the tree. If I bring up dwarf, let's just quickly open that. Sorry, it's open on my other screen. One sec. Let's get rid of some of my other tabs. Okay, right. So this is debugging using Dwarf 2012. It's to do Dwarf 4, but it's actually, it doesn't change that much. Describing data and types. Type composition, I think, is what we're looking for. So they have base type encoding, that kind of thing. And then, yeah, so a variable, the type is the pointer type, and then this is a pointer to an int star pointer x, and then const star argv, variable argv, pointer to a const car. Yeah. Now I'm quite familiar with this, having played with Dwarf a bit. I haven't had any major issues with it, I don't think. So where does the type def fit in? Let's see. Dwarf description for string and dupe. Okay, so we've got size t, that's what we're looking for. So size t is it just has a name and then points to the actual type that it is. I might use that, partly because I'm familiar with it. It just means the types have a consistent structure. Okay. Type def decal, type def decal, type def decal. Right, so the type is just a pointer to another ID. Right, we'll end up using our own IDs because we just want to ensure that these don't conflict, but we can just use an incrementing counter. So we're actually going to end up with an array in prefix order. Yeah, okay, that's simple enough. Which has the massive advantage of being O1 references to other things. Everything's going to have an ID. The ID is just going to increment. Sweet, yeah. Okay. Now that just means that, so it's going to be really easy for the user of our of this JSON to get IDs because it can do it in O1, but it means that while we're doing this conversion, we're going to need to keep track of their version of the ID and our version of the ID. Am I setting myself up for something stupid here? I'm not sure, but there's no point in just passing on all the complexity of that to the user. I feel like this dwarf-like structure is pretty easy. You just keep going through until you have the thing you want. Yeah. Maybe you have like qualified type and unqualified type just to, can you even do that? Well, I mean, that's the problem. So you could skip like, in this case, you could skip, no, you jump straight to pointer and these actually refer to the integer. So unqualified would be that. If you had, you could have that though. I'm not sure if that's actually meaningful, but let's assume it is. And so unqualified type would jump to the pointer here, skipping volatile, and working right to left. So I'm not going to do that. I'm going to leave that to the parser because it's pretty simple to parse. How much granularity do you want to keep that in? Just type. And then if it's a record type, it has members. If it's yeah, so what does an array look like in this in Clang's world? It's for right. yeah, size 4. We don't really want to optimize for I think what we probably want is both this method of reconstructing and then just a top level only. This is the description of the type as it, what do they call it? Is that qual type or yeah, I think qual type. Alright, so now we have a rough idea of what we want to do. So that's changing to type def type and it's probably useful to keep the idea of the decal separate from the type itself, or is it? Let's see. Well, we'll find out when we get there. Let's do a little bit more useful stuff first. Okay. So every node's keeping an ID. We're gonna have our own IDs though. Do I have? Sorry, just jumping around a bit. Let's print out something more useful. Okay, so we've got name. Let's just start turning this into JSON. Now, currently we're trying to do it in a single pass. It may end up that we have to create an internal structure and then put that out. Particularly for the type stuff, that's going to look like the most complicated thing. I guess one question is, do these types ever go forward? Actually, I think we can handle that even if it does, even if we do. Right, so we're going to basically have a struct node. We're basically making an array of nodes anyway, because each of them has an ID, and we need to be able to check those IDs. Okay. Let's just see where we get to beforehand. Right. Sorry. Let's see. Let's have a little bit of tea first. So I'm currently thinking that it would be a good idea to be able to output both a binary format and JSON format. Because if I'm going to use a C tool anyway, why not keep it in C? This is slowly growing in size, isn't it? But they should be exactly equivalent. I guess the only problem then is you actually need to be able to handle arrays of data like this. Particularly strings. Strings is the most awkward part. Not too bad, but you need to know. I think you basically need to do two passes. So you need to work out. You either need to put the strings at the top and work out what all the strings are going to be first, and then you reference into that, or you put the strings at the bottom and you put everything in, get all of the strings, and then go back and fix up the pointers. Except I guess instead of pointers you do offsets, and then you can do them kind of in parallel. So you have one buffer of nodes, one buffer of strings, and then when you're actually printing that out to file, you just append the strings to the you just append the strings to the end of the nodes. And then if you're loading that back into memory, it's easy enough to convert from pointers to strings. Sorry, from offsets to pointers, because you just add the base address. And then you can either do that on a one-by-one basis as you need the strings, or you could go through and do it for every single one. Although that, of course, assumes that you have a pointer-sized integer referencing them. Yeah. Okay. I guess it depends whether we want our format to be entirely standalone, because you could allow for so rather than putting the type name in here, you could describe the type name as an offset and length inside the actual source file. But being standalone is quite nice. I think ideally you probably want to just have a single file that you can convert into HTML. Yeah, because you don't have to load up the file, I don't think. I want it to be stupidly simple to convert from this JSON to HTML or whatever format you actually want. I think all of the IDs is always in this format, so we can convert from that to an actual number. Just trying to wonder which of these things we need to do first. Right, printing comment. We actually want to escape this. This we don't actually want. String split next. All right, so this is one option. If we're going to do it along with this, we want to see. So we're already escaping /n. Internal inline print escaped JSON string JSON the entire thing we want to go through and switch c equals JSON data JSON string dot data I switch on C. I'm pretty sure I've done this before. Escape JSON. Helps if I spell it correctly. What have I got in this file that's making it take so long? Probably the JSON file, actually. Okay. All right, one sec, sorry, someone's at the door. Let's get rid of del.ast.json. I think that'll actually go a bit faster. I think I had a couple of gigabytes of JSON. Can't even cancel it. That's great. Fantastic. Okay, while it's doing that, okay, it's ninja.ast. We don't want that. There we go. That's much better. JSON.star escape. Yeah. Let's just copy our existing version of that. Oh, that's actually quite a useful, even better API than I was going to do. Awesome. Thank you, previous me. I'm not sure if this is any better than the slightly simpler version, but I'm sure it's fine. I'm surprised that's not in the JSON thing. Actually, no, I'm not. So in fact, this entire thing skip to content. And just while I'm thinking about it, we can determine whether or not we want to skip that or not with a we want to be basically smart, and if the first one is like that, then we want to consider this the base, and if the first one is this, then we want to consider this the base. I think that's the way we want to do it. So bool initial first line space prefix. If I equals 0, I'm only going to do 1 or 0 for the moment. I'm not actually sure what's the better design choice, but like if you have that, you still want to capture it. Indent to depth, sure, why not? And then JSON print escaped, standard out. I think, what do we want to prefix? We want to prefix it probably with doc. And we'll try and output proper normal valid regular JSON, not just JSON 5, just to be friendly. Although trailing comments are so much easier. I mean trailing comments, sorry. Now, if I is greater than 0, then we're going to add a comma and a new line on the end of the previous one. Oops. It's better doing it this way because rather than putting one at the end, because in order to put one at the end, you have to know how many there are supposed to be. Because you don't know when the last one's coming, so you don't know whether or not to add one. It feels a bit backwards, but it is the better way of doing it, as far as I can tell. Experiment / run. Clang is 557. file string post. Yeah. Okay, yeah, I don't want to be doing it quite that way, do I? Yeah, no, that was incorrect. Sorry. That was if I had a full string I wanted to use. I'm actually doing it in parts. So we need to know whether if comment.len, then doc printf doc may need to do comma, new line. I might need to indent again. We don't want an actual new line. We want to do slash yeah, there we go. All right, one sec, I'm gonna come back. Or empty, I think. Yeah. There we go. All right. I will be back in a few minutes. See you in a sec. Don't forget to go have a drink, move around a bit. See you shortly. Hello, hello. Let us continue. Have a look. Shut the door over here. And we are just us now. So there's a couple of things to consider. We want a useful JSON format, but in the whatever format we actually do the conversion from JSON to your thing of choice, you want that to be pretty straightforward. Now, if you're using the JSON, then great. But if you're using C, then you're going to have that basically just transform into Markdown anyway. Wait, what? Sorry. Brain fart. You're going to have that transform into some C structures anyway. And you probably want an array of all of them at once. If you want to be able to, because you want to be able to reference from one to another. So we may as well just generate that in this anyway. Right, so rather than doing that name thing, we just JSON print escape string to stand it out. Maybe actually let's just specify the file here. File puts print change our std out to file there, and just move that decision one bit further up the hierarchy. And we'll leave it there for the moment. Let's see what we're missing. If we have a name, node flags and node name, print escape string, we want name we want to print the name, and then we want to just finish that off with something like that. And then let's just do this, everything the same, but replace name with ID. Then we want to print the range. Let's just keep this in the same order for the moment, at least. Right, for this, we're going to print range, and then we're going to open up some I think probably gonna have to do that in multiple prints. Let's just so print a file, print range. Yeah, okay, so this is only actually important for strings, isn't it? Because we don't need to escape the other things. They're just numbers directly. To do numeric ID corresponding to array position. And in the C version, you don't even need to store that because it's just implicit in the location. Which is kind of nice. So we're going to print the range, and the format for the range is begin so many escaped quotes, offset print range JSON print range internal void, don't care about the size that it ends up being, file stuff file source range fprintf file Okay, so sound dot star s string of the name, and that's going to then do offset send ZU DU ZU line new lines. We want new lines, and so car star nl equals has new lines, otherwise, and I think then you need to do indent as well. Depth. Otherwise, it's an empty string. Still a little bit silly, but indent equals has new lines. If it does have new lines, then we want it to be depth times 2, otherwise 0. So the trick here, what we're doing here is we're going to do, otherwise we have a space instead of a new line. I'll just call that separator instead of those new lines. Okay, so we're going to do here sep, and then indent nah, it's probably easier to split this up actually. Rather than, I mean, you actually can do it all in that format string, but I think it's more complicated. Let's do to there. File send s send dot star s, sorry, not dot star, just star s, sep, and then indent, and then empty string. And then we're going to print offset ZU range dot offset change offset to line, change offset to column, and that'll do for now. And then I really don't like the fact that they they changed the ordering of these depending on whether it's printf or puts. It's just an extra refactoring stage that you don't need when you're changing around. Changing around what you're printing. So we're going to print. One sec. Yeah, cool. So we're going to print. Yeah, so this is actually going to be the depth. Int indent plus indent n. Do you want any extra comments on that? Range. And then JSON print range file begin no.begin has new lines, false for the moment. Just going to make that variable here, and then we can add the comma if we want it. I'm going to make this just a C string. Okay, now maybe a JSON printf would be good. And then, is it VF printf or fprintf v or something? Let me just have a quick look on some docs if I can find VF printf. Yeah, VF printf. Cool. Okay. Inline void. Car constar file start file car constar name. This needs to be a global thing because I'm using it everywhere. Enum indent size. Let's make that capitalized for a constant. Indent size equals 2. Indent size. Name, depth, and then format, and then VAX. Okay, cool. So let's make that type safe. If we go to lib/c/c.h, which is the help library I have. Let size, maybe it's just an app.h. And go f. Just find where that's defined, if we can. Strings. So this starts at 1, whatever, 1, 2, 3, 4. So I need to look this up every single time I do it. FV. Right. VF printf. Let's just return that. VF printf file. No, I don't want this. I'm just doing this basically. Depth times indent size. and then we just pass in 0 if we want this to be in the same line as the other things. Yeah, that looks right. Then vf printf file format args. Was that? I think that might be it. Do we want to add this new line idea into here? At the start. Car star pre. Okay. So that'll look like JSON printf file separator. Oh no, that's going to be annoying, isn't it? I need to handle the commas. So let's see what I expect it to look like is comma, new line, name, let's move that round so that it's happening in the order that we're printing it. Now I know this isn't super exciting, but it's helpful to set up these utility things that will speed things up later. Occasionally. Sometimes it ends up just being a waste of time. We shall find out. So we're doing new line, we're doing offset, ZU range dot offset. change offset to line, change offset to column, and then depth plus 1 times indent size. And then we want to print this JSON value. The indent is the main thing that makes this awkward, really. Depth times equals has new lines. Plus 1. Depth. Depth, name, source range, suffix. Yeah, okay, that's kind of more in the right order. Depth times indent size. Okay, I think that's kind of what we want to see. So this will then look like begin, depth, begin. We want to have a trailing comma and we don't want any new lines. Do want new lines. And then we'll close it. JSON printf. I'll get rid of all these. Range. prefix, nothing depth, range. Yeah. All right, so this becomes file ID. All right, no, that's not quite true. Yeah, those two are the same because they're strings. Okay. All right, we're moving those flags into the node. No flags. Flags, change that to node.flags. Format attribute parameter 3 is out of bounds. Is it really? Why is it working in this then? Oh, as in it's one too far. One, two, three, 4, 5. Source range. Right, yeah. Dot begin dot. And then the same. I think these are now small enough that I'm okay having them in line. print range. Depth plus 1. Bool has new lines equals true for the moment, just because it's easier to read. I'm actually not sure why I'm bothering to make this so generic. Alright, so we're actually getting to the point where this is like a tree. So let's add some tree-like behavior. JSON print object. No, in fact, print object name depth and name. We use a little hack on for loops to do something. It's basically trying to create a defer, but so we use the for loop, go around the for loop once, and then do the iterate condition as the end of our scope. I explained that very poorly, but you will see that and see what's happening in a sec. Alright, I'm gonna do one extra thing to make it more useful. Cat1 define cat1 a b is a #b. Cat2, this is just a oddity of the C preprocessor. So we can do name stuff as int I then line 0 bang I plus plus, and then whatever. Okay, so not I, sorry. Bang all of that plus plus. So this is just the name of an identifier. We go through this once, and currently nothing happens, but we can use the comma operator, where the last thing in parentheses with commas in between gets done. So we can do let's just do this. File pre-depth name and it's just good practice to surround your macro things in parentheses, just to make sure that you don't have weird unexpected things happen. Right, so this does this and then evaluates to 0. It then goes through the inner scope of the for loop, and then we come up here and we do this. I don't think we need that. Yeah, let me show you how that looks now. JSON print object. We then have the scope of printing the internals of the object. Get rid of that. Right, let's just fix a couple of these things. All right, flags needs to move apparently in here. I do mean the regular assignment equals, thank you. Undeclared identifier range. Source range equals node range. Suffix. So this is just another object, and this means that our code will follow the same structure as the JSON that we're printing. Yeah. So why is that not quite working neatly? It is for some of them, but not for range. There we go. Depth +1. Right, yeah, then we need comma. All right. Let's just make that. Cool. This is starting to become fairly respectable. So on that note, I'm going to go for a quick break, and I shall see you all in a little bit. Don't forget to have something to drink, move around, do some push-ups, something like that. Right, I shall see you in a few minutes. Hello, hello, hello. How's everyone doing? Do say hi in chat if you're a real person. The other thing we could do is have some like JSON context here. Hello, Alpha Pork. Doing well. Good to see it. We could have some JSON context here, which includes the depth. Yeah, I'm gonna do that. Right. And then like I started this level. Just put needs comma. And then we'll have internal inline void JSON object push. And this actually can be probably either for objects or for let's just put the file in there as well. So you got past 100 sales on Twitter today. Congrats. Thank you very much. Now, we all know that that's just a fake milestone for the normies. The real milestone is powers of 2, so we're waiting for 128. What else do you want to hear? That'll do for the moment. JSON push. JSON context. JSON pop. JSON context. So plus plus context depth minus minus context depth. Now this is the here we're starting a new set of things, so needs comma equals true. And sorry, equals false. Oh, and then we can have we can put our separator here. Just space. Let's do item sep and obj sep, because we might want items to be separated by I don't know. fine. Now we know when we start a new line, then we don't need a comma at the beginning because we've already, we're about to do the first thing for that level. And then if we're popping, we're coming down, so we must have had something at that level because that's the object that we're just looking at. Yeah. Let's just make this more general. Pre-post. So it's gonna look like scoped JSON printf. Like that. So here we're going to do pre, and then here we're going to do post. So JSON push object. We need the JSON context. Am I going to Handmade Seattle this year? I would like to. I'm not sure what the current state of travel allowance is. Not like money allowances, and what the rules are around traveling at the moment. That might be enough. That's main internal inline void. Internal inline void, JSON push object, JSON push context, and then let's just change this now that we have a few things. Some context. We now have depth as well. Context depth. Context file. JSON fprintf context. So we want this the level of the previous one. Pre. I don't think we need a pre anymore because we're kind of just handling that implicitly. I guess context. context. We're going to do the comma actually in here. Do some printf. So that's going to look like there's no pre anymore. We just have context needs comma. Else blank. Internal line void JSON sep JSON context. Okay, so let's do it here because we might want to break it up. Sep context. Put a character, comma, into context file if and then f puts so we need to handle the new line separate, and then the depth star s context depth times indent size empty string context. And then the important thing here is that context needs comma equals 1 ready for next item. Until JSON push. And I'm putting a little bit more effort into this than I might otherwise because I think I'm going to reuse this elsewhere. Just pull this out as a little way of printing stuff. Right. JSON separator. And may as well indent as well. If then, oh, we're already indenting. Whatever, okay. So we've indented, we don't need to deal with that again. We can just deal with printing the name and then doing the thing that we actually wanted to do in format. Yeah, so the value. This is now 3. Alright, fprintf context name. Context file. Okay. And the reason I'm going to need that is for the pop. We no longer need this fprintf. We're just doing JSON indent context. Then we're doing JSON indent. Then we're doing fprintf context file Yeah. Make that parameterized. Move that out to here. Just because it's kind of pointless having these all separated out. There we go. Simplify that a little bit. And now we can do JSON setup, context, doesn't need comma, cool. Push level, pop level. I'm going to change these to just be push and pop. Car star, brace. Constant star, brace. And then I can do both arrays and objects with this. Pop level. And then JSON object is JSON push. Context. Name. Context. Name and open brace. JSON pop context close brace. JSON array, same but with cool. Yeah. Context, all right, so file. So you could have strings in an array. Is this the clang AST you're formatting as JSON? On the this is, sorry, let me bring it up. This is the clang AST that's being output as JSON from clang, and then I'm trying to turn that into a more useful JSON format, as well as an internal format. JSON print string. Name. So this is source code, internal clang AST plus documentation, clang outputs JSON, i.e. this file. I'm going to turn it into a more useful JSON file, and then we're going to have something that turns it from that useful JSON into HTML, whatever docs you like. JSON f if name and name 0. Cool idea. Thank you very much. We'll see if it works out. This is just a kind of generically useful thing for printing JSON, though I haven't actually done this before. I've done this for other formats, but not for JSON before. JSON print string, JSON f printf. I already forgot what that looks like. Context. Name nothing, and then JSON print escaped. Context file string. We no longer need to deal with the extra indents. Print string context ID node ID. So we're now just actually simplifying to the things, the elements in the code are the actual elements that we're using, as opposed to being more dependent on the actual JSON craft. Make these all JSON print. And just rearrange those so they're mapped appropriately. It should probably be with escaped because it's the only thing that uses that. And then we're going to use a hash if1 as a way of grouping code that's related. make it all caps. Then you can should be able to collapse the whole thing if for whatever reason it wants to play ball. There we go. Sometimes Vim just a bit slow on the uptake. Now I'm going to have a bunch of things that need fixing here. Alright, let's just change these to and the separator. Maybe I'll put that inside the ASD context. Or maybe I'll just group those into a general thing. May as well make those okay, I think that's it. Reset this to be a bit bigger. 615. Yeah, so these are all out of date. 2 to comma. Print object. So the only problem with the scope macro is that it's a little awkward to use. Oh, I already have it. Nice. Same with cat, maybe. 691 node. Oh, yeah, that's not a good idea. Let's just wrap this in an array for the moment. We'd probably end up changing that, but JSON print array. Yeah, no. ASD print node comments. JSON. Don't need depth. Sorry, it's just some fun, old-fashioned error fixing. I don't know how people work with non-statically type check languages. It's so useful just being able to rely on the compiler to fix up a bunch of stuff for you. JSON f printf JSON doc. String doc. I know it's a slightly special case because, yeah. Yeah, I don't get it either. I had to do some Python for work and it was just painful. Printf JSON doc. probably fine when you're used to it. Yeah, I mean, it's why there's a much stronger culture of unit testing in scripting languages, dynamic languages in general, because you have to catch a bunch of stuff. If you're going to catch it, then you need something automated to do it, really, and you don't have static stuff doing it all for you, so testing is the only real option left. And I can't imagine that the amount of time saved from having to put stuff in a structured type is... I can't imagine that makes up for the amount of time lost in writing tests. But there we go. JSON print array. What do you mean it's not real? How very dare you? Format string is not a string literal, fine. Have it your way, compiler. Source range equals does sometimes help if you spell it correctly. Only sometimes though. 631 what are we missing? Print node once. Too many arguments. print node comments AST JSON parent node. Get rid of that depth at the end. Aha. Aha. String. This needs quoting though. JSON file that can just be an F puts. And I need to make sure that I do the same for the slightly unusual string we have here. Fputs JSON JSON file. Wait, which round is it? Yeah. Make that an fput.c. Cool. I'm going to leave the user to trim trailing ones if they want them. Maybe. I might, just to be awkward, go JSON depth type indent size times JSON sep equals cool. Let's make it a little bit more compact. Seem to be doing the correct things with commas. Inner needs an extra object per thing. JSON value to object AST print node comments. Print node once. Oops. Print node once. We can then do JSON print object JSON empty name. I might change that later, but you can see that that looks correct for the moment. Although on the outside we still have an array. Yeah, so let's JSON print push, and this is why it's useful having the like simple things as well, because it's then easy to just easy to add ifs around it, where it's a bit more awkward with the scoped one. Although I guess you could, but it's a bit weird. We just don't have an outer thing currently. All right, yeah. Okay, so this is probably the point at which it makes more sense to divide going through their AST and printing out our AST. Currently we're trying to do it all in one pass, but I think the better option is to go through their AST, put it into a useful binary format that we can handle, and then go straight from that binary format to a useful JSON. Because otherwise we don't know at this point whether we want to capture anything inside. Yeah. Right, I'm gonna commit that there because that's made some good progress. Okay, git commit message, add immediate mode JSON printing. All right, let's rename it. Docs. Just because it's just to separate it from the normal WhiteBox stuff. I probably should have started a new repo for this so that I can make it public easily. But I guess it'll just be missing some of the history. Unless you can migrate some of your history to a new repo, which, as far as I'm aware, you can't. Let me know if that's if that's incorrect. Cool. Okay, so we pulled that out. Now let's start moving to pulling out the AST nodes one by one. So we're going to do the same as before. We previously set up some files chunks. We're going to do the same but with node chunks, right? And this just means we have a bunch of small small arrays, basically, of so one option you have is just to have an array of everything, and so you just have, oh, whoops, wrong one. Why is this not working? Capacity 100, too small. Not sure what's going on here. Right, it works with my thing. Okay, so one option is arrays, and that looks like, you know, one solid chunk of memory evenly divided with things. One option is linked lists, which these are, you know, anywhere in memory, and it might go from there to there, and then there to there, and then there to there, whatever. And then the other option is what I'm going to do, which I call a chunked array. You might call it an array list, but, you know, whatever. Is you have a chunk, and then you have links between the chunks. So you get the cache efficiency of arrays, only occasionally jumping to a new new chunk, and you get the ability to like add more elements while still maintaining a stable address for data of the linked list. Yeah, which are the main things. Now there's another way you can do that. Yeah, the downside of this is you can no longer randomly access memory. It's only really useful if you're iterating primarily. If you really want to be able to access randomly and still have resizable stuff and also have stable pointers, then you can use virtual memory stuff, as I do in my arena, and you make a really long, you reserve a huge amount of address space, which is basically just what pointer values you're going to be allowed to use, and then you actually only commit some of that, and then as you need it, you extend into the virtual memory, and so on. But virtual memory requires looking at operating system specific stuff, and for the moment, I'm not handling that, so I'm sticking with chunks. The other option, of course, is using malloc and realloc and stuff for arrays, but then they move around and the pointers are unstable even. And so for these, I'm just doing page size, basically filling a page with one of these chunks. It's a good kind of base unit. Cool, and then this is one of those times when templating or something similar would be quite useful, but maybe I missed it if you explained at the start. Do you have a second monitor or working on some stuff? Yeah, I have a second monitor. Currently, I've only got the stream stuff up on it. I'm not doing any work on it. All of the actual stuff relating to the code you should be able to see, hopefully. Chunk. Should probably make a size non-specific thing, right? So this I actually did the array count wrong previously, but so one option would be to have chunk header do that, chunk header. Now this is a little an extension that MSVC introduced that's also available in Clang and probably probably GCC as well. So you can do, if you just ignore this for the moment, if I just did this, then files chunk, I do chunk dot next, and it references through this into its members. If I do this, I can still do that through this, but occasionally I might want to access the header as a whole, so I can do that, and I can also do that. It's quite handy. File, so this is minus. Chunk header. Just shorten that a bit. And this is going to be 16 bytes, so basically everything should be aligned fine after that. I'm not doing anything that has a different alignment, that won't be aligned right with an alignment of 16. Right, let's see. Now, importantly, these are exactly the same in terms of the actual bytes. The only difference is that these pointers are typed differently, but they'll be exactly the same in all aspects. Okay. Right, so let's do terminal inline void star chunk push chunk element push chunks chunk size and then I want to push. Alright, byte star base equals byte star chunks last. I'm sorry. Plus size of chunk header. Turn base plus chunks last n plus plus times element size. I mean that. It has the downside. We can just memset it, that's fine. And if I don't have mem0, internal inline void star mem0, just mem0 pointer size mem set. Just make sure I don't get this the wrong way around because it's always chunks last, chunk size. Cool. And now this becomes let's add in this just for the C++ people out there. Chunk element push. Chunks star cast files to chunks. Size of files equals size of chunks. type, just to make sure it's always the same. Okay, what are we missing? Sorry, I'm aware I'm doing a fair amount of infrastructural stuff that could be faster, just copying and pasting. But I kind of want to use this elsewhere, and I haven't spent the time to do this before. And I feel like doing it now. Anyway, so chunk L push. Size of file. Wait, can I get that directly from this? Because that would be great. Chunk header, files chunk. Size of files first. Files 0. Page size, page size. I'm aligning this to the page so that you know, it all gets loaded as one rather than multiple. Yeah. I'll step through that to make sure that it's right, but I think that looks about it. Can I just confirm at this point that this is equivalent to a type check, to a chunk header? I can, I think, actually, if I do generic that's not worth it. You can, but it becomes really hard to read. So I'm actually yeah, okay. Um, chunk header type. Okay. Union chunk header and the thing we actually want, which is wait, why do I don't think I even need the its type. I think I can just use my type. Now let's do this like differently. Right, so we get rid of that, and then we're going to do our chunk is the header followed by chunk header type. A union of the chunk header and no, I don't even want a union. No, I want a chunk header followed by this array chunk type, L type, chunk. chunk size. Chunk size minus size of chunk header over size of L type. Okay. Right, just trying to avoid some slips from the user side. So the chunk type is files chunk, files page size. That may change later. That's fine for the moment, I think. Cool. And so coming full circle back to it was the nodes, wasn't it? Nodes chunk. Nodes chunk. Chunks, nodes, chunk. And maybe this should really just be inside here, like this type definition. I'll be back in just a sec and we shall find out how it's going to go. I'll leave you in suspense for a few minutes until then. See you in a sec. And we're back. Exactly on time, actually, this time. Right, I'm just gonna go ahead, because all of these seem to be now in this format where we create a chunk header and then turn that into this, whatever. I think, let's just try it without, I just want to try it without macros for a sec and see if it does what I expect. If I do that inside there, is that going to work okay? Oops, daisy. Run. Chunk header. Element type. No, that's right, because it's not. I don't want that. I want chunk header. So there's a couple of things here. All right, first of all, I think let's get rid of this chunk header as a separate thing, and we'll just make. No, I can't do that. Damn it. Size of chunk header. Alright, if we do it that way around, rather than referencing chunk header directly, that might actually work. Okay, so now this we're going to define as a chunk element type void element name unused. Let's call it data. Use bytes, and then we can actually reference it later, which would be slightly handy. What size do we want to give it? That's the question. I think probably 17. So that's 16 plus 1. So we just have, it's basically just ending up as a a 1 byte array at the end. Let's see where that breaks. No, never named chunks in structure chunk header. Um, 170. All right. Chunk L's N. Now ideally I'd cut this down to 4 because then it'll get passed through as registers even if it doesn't get inlined. But yeah, let's just work with that for the moment. Not equal. I don't want to equal. Okie doke. Count of chunks less chunks. Files last files. Okay, 514. Nodes, page size, okay, let's try that. Cool. So what happens if instead of doing that we do this? Type name does not allow storage class to be specified. What if we only have nah, not worth it, because I want to be able to reference the chunk by name. Okay, actually, what about if the type def is outside, but the internal definition inside? Because then I can move that into here. Name, size, byte data center. If I can just minimize the number of macros that are being used, it's going to be better. Too few arguments. Nodes. Cool. We should be working again. And then I think we can now simplify this again to chunk size, so that's just this. Minus size of struct. Extraneous closing brace. L type. Size of size plus size of type star. Let's see. Extraneous closing brace. Oh, right. Cool. Expected colon, end of declaration list. Because that means we just have one macro, which is, oops. And it's pretty easy to read. You can just it looks like a struct. The only reason that I do it inside the struct rather than outside is for type checking from the C tags thing, basically. Whoops. Okay. $147. Oh, there. So, I guess the difference that's notable between this and templates is that we're using the same structure for types itself, but the types themselves, but the actual function is the same for all of them, as opposed to having a new function per instance of the type with templates. Suspense is clean. Well, hopefully we can rectify that shortly. No member empty files in struct files chunk 186. 186 even. Files in struct files chunk. Ha. There we go. We are up and running. Okay, so I know that was a little bit of a diversion. We have I think there's one more thing that I'd like to do with this. Right, yeah, so we've got this chunk element push, and all of these are statically determinable from the type that we're going to pass in. So I'm going to do some automatic casting. But we're going to do some kind of ad hoc type checking in the process. So hash define chunks L push chunks size of now should we just call this data, chunk data? I'm happy enough with that. Size of the first data thing, count of all of the data things, size of chunks first. I guess the only thing we want is specifies alignment, because that's not necessarily obvious from this. Actually, I think we're always going to want to have, like if we're doing cache size ones, it's going to be the same thing. Push align. Okay. Right, that is now kind of nice to use. This is all known at compile time. Size of, count of. Fantastic. I guess we just want to make sure that these are properly escaped. Not really escaping it, just wrapped. And that's all right. Just comment in these. You have to use that C style comment because otherwise the backslash continues the comment onto the next line. Just for the sake of fewer places to look, else and chunk size line. That'll do. Here we go. Yep, so now I need to get rid of these extra Interesting. Okie dokie. Let's run that. Ah. Optional padding. Page size 4096. And how much was it? Align the size 4080. So we're 8 off. No, what? 16 off. Or did I just pass the wrong size? Hopefully. All right, chunk size. Bless you, thank you. Size of star chunks first. Yeah. I could just union this with a buffer, couldn't I? Union of that struct with let's call it a buffer. No reason not to. I think that should fix it. What's wrong? Chunk size. I think we just need a couple of extra escapes. Aha, missing one. There was a warning there. Let's make sure we catch that. Incompatible pointer types assigning to union. Anonymous union star from chunk header star. Files chunk. Just so that's expected to be a thing. Oops. Okay. Now are we now free of warnings? We are. Aha, awesome. Alright, this is slightly more convoluted than I wanted, but it's not too bad. Can we do size of what chunk header? Size of file. Right, yeah, 32, and then there's going to be 16 after. Yeah, okay. Cool. Let's just have a note here. Here, so we can determine chunk size with size of. Awesome. Alright, so we've got, I don't think this is an egregious use of macros. We've got one here, just being the internals of a type. I think it's fairly reasonable. We've got these, which automatically get some of the basic data, and you can opt out if you just use the double underscore version. And then just one macro call per chunks thing that we want to have. I think that's pretty reasonable. And then we just have one of these functions that'll hopefully be optimized out almost completely with all of the known size things. Nodes chunk. Play coffee. Hello chat, how you doing, Andrew? I am doing well, bro. Thank you. How are you doing? Play coffee. Good luck with your work today. Thank you. Vim +1. Thanks. Yeah. It's not too bad. Alright, just make that a bit smaller because then we're not really using it. Yeah, so this is one way of making generic types in C. There's a couple of different ways of doing it, mostly useful for collections. If this had more stuff involved and required like lots of functions that each should be applied to a typed thing rather than an untyped thing, then I would have done this in a separate file and defined some stuff before the file, then hash included the file, which is what I do with hash maps currently, at least. Like, can't really complain about that. That's pretty good. I know some people will avoid macros at all costs. I take an intermediate approach to limit their use, but C is not a perfect language, and so occasionally you want to add constructs that it doesn't really have. So let's do internal inline node star node push nodes chunks chunk out push nodes node star result equals that. Cool. Okay, so it's probably going to go in the AST context. Files, nodes. Uses if lock as the previous one, it same as for the previous lock, it is omitted. This we keep track of clang omits it. We keep track of previous values here. All right, let's move nodes So let's make another group. Like I said, it takes a little while, for some reason, for it to cotton onto what's going on. There we go. So we'll move the nodes up to files. Move the chunks out of there. We've got some other stuff in that mixed in there as well, but that's kind of right, I think. Let's just pull that out. Now we're probably gonna hit some out of order stuff now. 275. Source range. Let's see what's next. 184. All right. Yeah, give that a bit of JSON context hasn't been declared. AST print node comments. I think all the JSON stuff should be moved above the AST stuff. String from source range. String from JSON string. Let's put that next to the other source range stuff. So you end up with a tree of these sources inside files, inside whatever. We back up and running. Cool. Git status, git add up. I don't need to get status actually, sorry, forget that. No, no. Yes, yes, yes. Git status. Actually, I'm gonna wait for that. Any questions from anyone in chat about what we're doing, why we're doing it, how I'm doing it, anything like that? Cool. Git commit message docs add generic chunks list of arrays. Implementation. Oh, let's just Alfbork, could you explain the reasoning for using this chunk thing? One sec. Yeah, I will. Yeah. Refactor. Group related code. I was slightly distracted when I did initially. Okay, yeah, so when you have a basic collection of items, there's a few different ways you can do it. The standard thing is you have an array. Now, if you do this as a fixed size array, obviously you set this size at compile time and you never grow it. Or maybe you allocate it once at runtime and then after that you never change it. So this is good, and you can take pointers to any of these elements. You can randomly access anywhere in here. You can it's very fast to iterate over because if your cache is like that many, then you're looking at all of them in turn rather than only looking at that one and then jumping to here, whatever. So you actually use the entirety of the cache, which is always a good idea. So this has a bunch of advantages. The disadvantage is that it's awkward to grow. So if you want to grow it, you can reallocate the thing, but that means that all of your pointers are now, if you had a pointer to here, it's now just pointing into null space or invalid memory. You can continue using indexes if you want, but if you want to use pointers, realloc stops being viable here. So the next option for lists is using, next option for collections is using a list. So you have each item links to the next thing, links to the next thing, links to the next thing. So this is very flexible. You can, add as much as you want. You can insert stuff into the middle, which is nice. You can, what else is there to say? I mean, those are the main things. But so yeah, pointers are stable, or can be, depending on your back memory. But you massively trash the cache when you move between them. Are you off? Okay. Cool. Have a good time. See ya. Sorry. So you goodbye spam. Okay, so you've got stable pointers, but you trash the cache as you iterate through these. So a chunk is kind of somewhere in the middle of these, and you can actually think of this as like a chunk of one array element, and that at that point you have a sliding scale between linked list and array. So you fit everything in cache when you're moving through. You can insert is like somewhere in the middle of these in terms of cost. Yeah, so basically iteration is fast. You no longer have random access, unlike array, and you still have the flexibility of being able to allocate stuff with add on more stuff later and keep stable pointers. Does that make sense? There's another option, which is virtual memory, which is a whole separate thing. Right, ... So maybe. Okay, so yeah, the key thing is you have a big enough thing that you can, when you're iterating over it, you're basically filling the cache as much as possible, and also you can prefetch the processor will prefetch the next bits of data until you hit the end. Doesn't inserting in the middle of a chunk become kind of complex? Moderately, yeah. Although I don't have any, I basically never have to do that. It's slightly more complex. And you're doing basically the code for both a list and an array as you'd insert. And there's also a couple of different ways you can do it. I mean, if you're doing insertion, then I guess you lose stable pointers with this. You can't really do insertions and stable pointers. If the array is, I mean, if the order is not important, then there's no reason why you would insert. And if the order is important, then you can only insert until each of these is full. Because if you want to insert like somewhere in the middle of this, then everything else gets moved, and then that breaks your stable pointers. Yeah, so pro iteration speed, con can't random access. Yeah, with requirement stable pointers. Yeah. Right, so next thing. Let's find our node. Turn ID. Um, So the main advantage is the fact that you can grow the thing without being punished with the cache or pointer stability wise. Precisely, yeah. Much more succinctly put than I put it, thank you. Yeah, I've been streaming for over 6 hours now, so my ability to explain things is going downhill. Not that it was amazing to begin with. Particularly didn't sleep that well last night. But we got there in the end, so thumbs up. Right. I appreciate your understanding. Thank you. Okay. So here, let's turn this into a number. If verify string has prefix value not x, expected hexadecimal ID. Side. I'm just using for string ID string equals string skip val 2 ID string dot len. Okay, so let me just remind myself of just gonna do it in line here, or no, let's probably do it outside. Size size num from hex string hex string node.id equals num from hex string. Size result equals 0. Result. Okay, so if like just remind myself of the ASCII table. Just bring this up. Table. I only use Edge while streaming because I don't use it normally, and so it doesn't ruin my normal set of tabs. Let's whatever that will do. Okay. So we're gonna put this to upper. Car digit equal to upper id string dot data I. So if digit is greater than, I'll do it ASCII irrelevant actually. No, this is going to be ASCII. Let's see, what bit is that? If I open this, I can use this as a small calculator for 61, 0x, 97 and 65. 97 binary, 65 binary. And 48 binary. Hmm. 48, 65, 97. I'm not gonna mess around with it actually. Let's leave it as 2 upper. If let's make a table of the things that we want actually. It's only 255 bytes, so it's not too bad. I mean, you could make it so it's actually 255 bits. 256 even. 608, so 32 bytes. Digit bits, 32. Equals, and then we can set individual things. So we can set, all right, this is just turn them on or off. Actually, let's change this. Actually, change it. It's slightly more. It's easier if you know that it's going to be decimal because you know the range that it should be in. So A equals A minus 10. Yeah. D, E, F. Okay, we're gonna so everything else is going to be set to 0, right? So we want to be able to both determine whether or not it's valid and also... Oh no, actually we don't need to do anything special because these aren't 0. So that's... These are ASCII 0, which is actually whatever it was, 48. So if U1 string.data I verify D digit sub I so not a valid X digit. Assuming that it's correct, assuming that it's valid, then result times equals 16, result plus equals plus equals digit minus digit sub. So the first time round, result is 0, so times it by 16 does nothing, and then we add to that the value. So like a, if we had a, then would be a minus 10. So that would evaluate to 10. Or if we had yes, this is digit val plus 1 . Yeah, so we leave the 0 value so that we can check that. And then we just correct it by subtracting 1 later. And if you didn't have to verify this, then, or if you didn't want to, then you could just make these back to 0, not bother verifying it, and then, you know, happy days. Just make that a little bit smaller. Very nice, very nice. I do like C's designated initializers. They are handy. So I bring up my Twitch chat again. Cool. Yeah, this is the actual meat of it though. Yeah. So let's do num from text here. Let's look at the result. Let's compile. ID string.len. Okay. That's because it should be hex string. ID sent ZU again, same as those. Is your string type just a char star and length? Yeah. Well, the one difference is, well, it's kind of probably not relevant to your question, but I do it as length and then the data, because that way if you're typing, if you have a string inside another struct, then you can't accidentally set like struct whatever data equals some other values, 2, 3, oh, I need a string, hello, some other data, like leave it like that. So this would actually, if you had char star and then data, this would evaluate to a length of 0 with a pointer. So it looked like it'd be correct, but it's not actually. Whereas if you have it this way around, the way I have it around, then this will cause a compile time error normally. Hello, Alpaca, and I'm not sure. Sorry. Thanks for the handmade stuff, handmade things. How you doing? Yeah. Need commas apparently. So picky, these compilers. Seven, 4, 7. Right, yeah. So this is his. Actually, no, that wouldn't have triggered that, but similar type of thing. Whoops. Nice. It needs to be shorter for a sec, so that, or I could just do the build, but yeah. All right, so let's have a look in here. Let's look at this. Yeah. So we look at the result. We can see result in hex, and we can see the hex string.data. 1A16625 DCB8. That looks like the same value to me. Great. Okay, cool. Let's just move this to here as well. For some reason, hex string equals string skip hex string. This is fine for the moment. It's not super generic, but that'll be all right. Two 202 9326168. Excellent. Cool. And from hex string. No. Yes. 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 Yeah, message docs. Convert ID hex string to number. And the reason that we want it as a number, other than just being smaller, is that it means that we can do a direct comparison while iterating through our nodes. Because we're going to want to do that for basically every ID. Let's turn this into JSON. Oops. JSON print node once. Now we want actually we want two IDs. Oh no, we just want one ID. I'm going to call that the LVM ID. Let's see what that breaks. 5 ID. Okay, cool. So when we print it, for the moment, let's print it as a string, not x. ZX. There we go. And let's just include that with the previous commit. Git commit amend, no edit. Right. We're now going to go through and we're going to record the yeah, we're now going to go through and record the nodes and then print the JSON separately. AST print val, it's kind of unnecessary currently. AST get lock, get range, AST print node comments. So key. The key is useful as part of this, but we don't use it to store it. Get rid of the printing. And that means that we no longer need to check whether nodes are ready to print because they're always ready to print. Or we do everything that would be needed to prepare them to be printable before we try and print them, as opposed to doing it kind of inline here. I believe it's called like loop unjamming, when you disaggregate stuff that was in the same loop and move it into different loops. There's probably a few names for it. Should print quick look. Let's just sit down for a bit while we do this slightly more sedate bit of work. How much my mess in my background is visible. Let's just hide some of that. Cool. How often do I usually stream? First time catching me live. I'm not regular about it. I'm trying to be more regular. This particular mini project, I've just decided to stream all of it as opposed to doing most of it offline. The actual WhiteBox stuff, I tend to, I don't know. I'm gonna be doing it again regularly. I think it'll be moving to weekly on Friday from about 3, maybe 2 or 3 p.m. GMT. And yeah, I don't know. Are you on the WhiteBox Discord? We have a role there that gets notified every time I put up a stream or start a stream. How am I finding it? Hard to focus? A little bit. This is less complex than some of the other stuff I've been working on, and so I don't find it's quite as taxing, but it's still just the fact of talking and coding at the same time does definitely slow you down a bit. Cool. Yeah. Let me just put in chat https chat.whitebox.systems. That'll redirect to Discord. How did you come across the stream? Did you just find it on Twitch? Or on one of the other Discords? Handmade Discord. Gotcha. See my box of climbing stuff in the background, ignore that. Okay. Right, yeah, so we're doing some node stuff. Keeping the kind as a string currently. Getting the name, cool. Getting the ID. Okay, so let's get things like struct and go. Record decal. Tag used. Yeah. name. Or just leave it as tag for the moment. Tag used. What other things do I definitely want to keep? Call type. Field decal. That's fine. Just what Dwarf called a member, but no biggie. Type, qual type int. Right, let's get something close to what we have. We won't do inner types, but we can do all the other bits. Let's make sure we're outputting the right format. Okay, so first of all, get nodes. First of all, we immediately push node push, yeah. Node dot becomes node arrow. Yeah, we're going to get rid of that printing stuff. Oops. Yeah. Right, so we pushed on. Then JSON print nodes, AST Alright, so we have basically a hard break between their JSON and our JSON. So let's go back to JSON printing, cool, yeah. Go to the bottom, go to the bottom of that, and then add our new JSON print nodes function. Nodes, and we actually probably want to pass in a JSON context as well. JSON. So our AST context no longer uses oh yeah, we never actually did put it inside. That's cool. We no longer need JSON print in there. JSON. Cool. Okay. We get nodes, and then we print those nodes. Cool. So, JSON print object. JSON. It's an anonymous thing. And then how do we want to do this? I think what we're going to do is, rather than have depth, have keep track of what parent we're looking at, and then here we can add a depth thing. And so anywhere that we're looking at depth, let's just have a depth here as well. Okay, so we got our depth. We're going to set that whenever we change, we push and pop. Push level. Let's write the usage code actually. Print nodes. So we're going to go through all of the nodes in turn, in order. Although that's not how we're going to do it, actually, because we have chunk lists. Okay, so for chunk, hello, Finding J, how you doing? Great, looking for a new gym. Oh, cool. Int, right, so we can easily determine the depth of the node. Node depth, node star node. For node start it equals node. Okay, so there's an off by one potential here. If we pass in the root node, then it'll be valid the first time, and then we'll add one, look at the parent, and then it won't be valid. So the root will be 1. So we really want to start with node parent. Oh no, this has completely changed the oh yeah, for what? What's that, sorry? This might completely change how the printing works. Wrong chat. Okay, no worries. Let's just try that. JSON print node once. Node once. This doesn't account for whatever. Chunk data index, I think. Take that. Tell me there's no tag. Is incompatible. Okay. AST get nodes. Yeah. Too few arguments. Yeah. Okay. Where are we breaking? Oh, we're just not printing anything. Cool. Let's just pause there. Have a look at sorry if that knocking the mic is annoying. I am missing total n. Interesting. Okay. Chunk put L push. Cool. Let's try that. Total 165. 28 times 28 plus 28 plus 9. 65. Cool. All right. Depth. That's mad. What? Let's just make sure that's zeroed. Although, so I'm completely overwriting one there. No, I'm completely overwriting one there. That's interesting. Those should have been zeroed anyway. Right, that's not the issue. Clearly. Let me just go into my experiment / build.bat because I'm used to having a bunch of warnings on. I don't know what to tell me about unused function. Missing braces. W no unused function. What was that? W missing brace. W no missing braces. That's more useful. Wait a second. Length is 69676. 69. Okay, not quite, but right, let's have a look in AST get nodes. Um, let's have a look at our node. New function breakpoint, new processor breakpoint, node, depth 4. Okay. Oh, helpful. AST nodes first data. Alright, so why is that not set? First and last chunk is still the same. Okay. I think this just kind of looks off by one. Is that an issue with my type generic chunks? That's annoying if it is. Here we go. Right, so node here does have the parent. Which looks correct. Node star result. Yeah. I don't even understand how it could be possible, like why it would. Okay, just put one there. Right, so nodes now has a couple first. Data, so what's okay, so I think it is an issue with the with the way this is pushing. Sorry. 018. That's incorrect. It was probably just that hasty change just earlier. Chunk I'll push this by base chunks. Oh, something that fixed it. I assume it was an alignment issue. Let's just have a quick look. So now result FO10, FO10, cool. Awesome. And print node once. So there's still some stuff to fix there, like the range doesn't look right. But I'm gonna be back in a few minutes. So let me just sort this out. Cool. I will see you in a few. Make sure you go grab a drink of water or go move around, whatever. See you in a sec. Okie dokie. Let's continue then. So, the source range isn't getting set. Let's have a look at that. Let's see. Object, location and range. Let's just get nodes. Assert node. Range. Source range is valid. Cool, that triggers. Node. Type visibility attribute. Okay. I guess our should print becomes should push, doesn't it really? That would have been smart. So okay. So we're gonna push. When are we gonna push? What did we call it before? Node is ready to print. And I had that here, I think. Signify hunk diff. Yeah. So we'll fix that. But rather than printing JSON just call it node is ready. Now we're going to set node pointer equal to nodes push. AST nodes node. JSON value to object, AST get nodes. Be pushed onto node needs to be pushed onto the array before it can be referenced. So it's worth doing these assertions. Let's try. Let's just add. Interesting. Sorry, full coder. Let's have a look at these other flag states. Okay, so let's just look up. Love Remedy's feature for this. It just walks up the call stack until it finds this, and you can set a specific number of stages to walk up. Or you can use as many as it needs until it finds it, which is normally useful. Okay, so we've got our ID, that's what we expect. Let's have a look. We now have a kind as well. We don't have a range yet. Let's have a look. Oh, yeah. I think we might just skip the translation unit decal. There's not a huge amount of, because it's kind of different from all the other ones. Let's just have a look at the JSON for that. Or maybe we just do a custom range when we don't find one. Let's see. Range. I think it's going to be better to do if bang source lock is valid, result equals, just have a file source lock. Let's set that to string path contents. Yeah. Okay, that's actually probably more of an issue. Okay, how do we want to handle? Maybe we just handle it on the printing side. Print nodes. If node kind equals continue. Right, yeah, but we still haven't solved that issue. Okay, so we're gonna have to change. We have it, the ranges flag will change meaning from has a valid range to we have encountered the range for it, which may or may not be valid. Not be valid. Okay, what are we missing now? What does node not have? $39. Node flags and node deck already. What are we missing? One, 0, 1, 2, 3. Node name. Okay. Let's just set that equal to true if it's a translation unit decal. Right, so if it's decal, then then we're going to set the name to true. Pointer type. Okay. So currently we actually only want to recurse on decals. Let's invert this. Okay. Why have we got these repeats? Why is that happening? That's somewhat odd. It's not doing appropriate nesting, is it? Right, so this is insufficient. This needs to be a recursive print. Or at least it doesn't actually need to be recursive, but it needs to not have an external structure stopping it from being. Yes, we don't want that anymore. Yeah, in fact, we just don't want individual prints. So let's just move all of that. I think I'll probably stick with the inner concept. The other option would just be to have everything as an array. And everything points to previous things based on index. I mean, let's do JSON properly. Let's give it some depth. I guess, I mean, either's proper really, but all right, we never check that anymore. So we want to let's just do it this way initially and see what that looks like. Okay. Parent. Right, is compound just isn't being used, so let's ignore that. Alright, so parent is this, record decal union with right, we're pushing twice. That's why. Tool N and if we haven't yet pushed anything, or if nodes last data nodes last n-1 dot lvm id is different from node dot lvm id. Have you said your daily Wazingo? I have no idea what that means. I mean, I guess I've said it now, but no idea. It's greater than 0, then right, if we don't have a result, hopefully that should cut out those repeats. Not quite. All right, fine. Let's or the other option, I guess, if we want to avoid storing that extra data, is move this elsewhere, basically. So alright, if the type is not a JSON array, array, the array. Very shortly. One moment.
You don't have to order them right now.
Alright, I'm back. Has printed. Let's see. So this is a child of this. This is a child of oh, weird. Oh, weird. Okay. It's not prefix order. Oh wait. Oh no, sorry. Let's just dump that to out.text, or even out.text, out.json. Oops. JSON. Out.json. Print range needs to include the file. I said it when I was saying the asking. I read out your question, but I still don't I have no idea what you're talking about. Print range. Not print range. JSON print. Nose print range. Print string file begin dot file range dot end dot file. Not sure if you asked this before, but what is this project? We are replacing Doxygen. So rather than using Doxygen's pipeline of source code to Doxygen internals to whatever, XML to HTML, we're using source code to Clang's AST to a JSON output of that AST to our own version of JSON with docs attached to particular comments. Doc comments attached to particular AST nodes, and then do what we want with it. Did not follow any of that. Sorry, it was quite a quick recap. Didn't follow any of it. So are you familiar with Doxygen? It outputs things like let's have a look. Let me bring it up. LLVM MC inst. So LLVM has their own Doxygen stuff. Well, they output all their docs in Doxygen, and you get this, which is moderately useful, but not particularly. It's slow to generate. It doesn't use Clang unless you opt into it. Doesn't pick up all the information you want. You're forced to use their particular format. This isn't a great example because there isn't anything particularly. No, this is all fine. I don't object to any of that. Let's have a look at that maybe. All right, none of this is particularly bad. Sure. But anyway, so the actual comments themselves here aren't too bad, because they're not doing anything particularly clever. But as soon as you want to do anything clever, then Doxygen gets in the way. Or you have to do it in Doxygen's way of doing it. And even if you don't want to do anything that's kind of dumb, but is somewhat different from Doxygen's standard approach. I guess that's not really a typical Doxygen thing. Let me find a typical Doxygen thing. Right, so these are written in Doxygen with an extra extra output from m.css. Let me see if I can actually find the docs, where the docs generated from. Doc. Source, maybe Magnum. Right, so yeah, you end up with a lot of this like @ref trade API, @ref refs, @section, @ref whatever. And you know, fine if that's what you want, but it often gets a bit awkward to read in this format. It does have basic markdown support, but you can't do things like definition lists or there's a bunch of things like just like simple multi-line tables, things like that, which just gets frustrating. Now, natural docs has a nicer way of writing documentation, but it doesn't apply to it. It only applies to things you've explicitly documented. You don't get any of the you don't get any of your functions and structures and whatever auto-documented. So they basically have just like a yeah, so this is the description, which is, as you can probably tell from the name, intending to be a more quote-unquote natural. What now? If range dot begin dot file path I guess actually that should just be if range if source range is valid, range. Okay. Right, so now we can have a look. Parent is presumably that's the translation unit. Yeah, so we have a bunch of things that are just relative to the translation unit. Let's print the index. Okay. Chunk index times count of chunk data plus I. 2, 3, 4, 4, 5, 6, 7, 8, 9, 30, 31. Cool. I need to check if there's a way of forcing these full paths. Different type of doc string. Um, So this record decal has a comment, and then these field decals. Okay. Yep, that seems about right. Alright, so I think what we want to do with this is actually attach it in we want to have it as a variable inside the actual node. Alright, so we've got a full comment. It's just attached to the parent, I believe. And then we just return. Okay, so if we just look at this briefly, we can actually change how we do this slightly. Because we always have the ID and the kind for each node. And range, I think, as well. Okay, we always seem to have those. ID kind lock range, ID kind lock range, ID kind lock. Okay, ID kind type. But ID and kind are always there. Okay. Node object start, ID element. And we just avoid the loop altogether, and it also means we don't have to do the extra kind of iteration-y stuff. Assert that it's an ID. JSON value to string. Kind L equals IDL. Next. Kind. So we're going to set the node kind. So we can actually get rid of these node kind and node ID because everything has them. Helps when you save. It just means a couple of fewer things to check on every single go round. Let's just make sure it looks past the smell test and then double check. Cool. comment. I don't really need comment anymore because I don't want to keep those as their own nodes. Node comment. Yeah. Should recurse. I quite like this construct, the else for statement. So we're gonna go with this. We're gonna take this and get rid of that. Okay, so if the node kind is full comment, then hey alpha book, else for, yeah, because else can just take any statement, and so you can take for, and then do all the stuff inside. You can also do else switch. That also works. In the same way that you can just do like else x plus equals 1. It's just any old statement. Right, so if the node kind equals full comment, then the parent doc where is that being set, the doc? Right, it's being set as a separate node, but I kind of want to attach it to the nodes themselves. Node string doc attached documentation, the thing we're really here for. Node makes sense, just never considered before. Yeah, it's it looks a bit weird the first time you see it, but it's actually quite nice. Yeah, so parent doc equals Um, oh, well, I need to actually get this stuff. Oh no, wait, do I? I haven't got the range yet. Yeah, okay, I'm just gonna go until I get the range, and then where did I get to? Get nodes. If is comment. Go to end. No. No. Parent doc equals string from source range. Node dot range. Fine, I'll get rid of the else for. Yeah, we actually need an end thing for that to work. Parent. Okay. Then I guess parents are becoming less const, aren't they? And need to change the way they're printed now. I really want to just add this, don't I? think I'd like this to be specified, like all done already, so the actual printing is super duper trivial. That would be nice. I guess I'll just do the escaping this side. I think I want this to be print string node doc. If node doc len that's the idea. I could pre-escape it, couldn't I? Although that requires having a different print mechanism. Not that that's super tricky. We're already doing escaping there, so that's kind of a necessary thing. Doc. Str doc equals parent doc equals we're going to end up probably joining doc strs. Docstrs equals g push. Just need a way of putting stuff onto there. Yeah, so we're gonna do all of the skipping that we want. Line doc. So we're gonna use strings push doc strings. Line. We're then going to join on str join, is it? Sep string separator. Also with a new line. So we're taking out the new line and then adding it back in. That's all. Okay. Okay, let's try that. What's wrong with that use? First line space pre. If I spelled it right, did I save it? Oh right, it did actually work. I just missed it. Cool. Doc. Right, this is getting close to useful. They're not complete by any means. Let's actually make them children. I prefer children to inner. I think it explains the structure better. Right, so we're going through, we're printing them. Get get commit docs separate JSON reading and printing passes, and add docs as doc as node field member. Yeah, actually, that I just made up my mind. It's correct that we're not doing this JSON escaping at another point, because we might actually not want to have it in JSON. If we don't have it in JSON, then it makes sense to not have it escaped, unsurprisingly. Yeah. So, what have we got to do next? Let's give it some children. There's a couple of different ways we can do this. JSON print nodes. I think possibly the easiest way is just to keep track of the depth. Logical index. We could just keep track of what the last one is and do the depth, and if the depth changes, then we do stuff, right? JSON to depth. Depth. Actually, this isn't. No, it's not quite right. It's nearly that, but not quite. Right. So if the let's go int node depth equals node depth node if depth is not equal if depth is less than JSON if it's greater, then we're going to JSON fprintf, no, JSON print push object, push array even. Oh, I guess it's not done quite like that. Push, yeah. JSON print push, JSON, we'll call it children, and it'll be an array. Depth is less than JSON depth. Then, here we go again with the else for. Okay. JSON print pop, JSON first of all we close the object, then we close the array. I don't think that's going to be quite right, but I want to see what it looks like. JSON print push. JSON object open. And then we just have this again. Depth. We should be even once we hit that. Maybe I think I should be there. JSON finalize children arrays internal inline void. Pop. JSON context, JSON and int depth. JSON pop children arrays, JSON depth. And then at the very end, we pop back to 0. Called object type void isn't a what? Alright. Just the old semicolon error. Yeah, that's the problem. Oh, sorry. This is meant to be if depth is less than JSON depth. Oh wait, no. That's alright. This is still doing that. I thought I'd got rid of that. Right, I'm assuming they're in prefix order currently, which may be an invalid assumption. Let's see if I was right the first time. No. Okay. That just doesn't seem right, though, does it? Alright, I'm just not finishing things properly. Okay. JSON print pop. Why is that behaving weirdly? That's weird. It's not supposed to be doing that. Okay. Right, because we're already actually off by 1 here. Alright, I'll be back in a sec. See you shortly. Okay, I'm back for a bit. I just want to get this done, and then I think I'm going to call it a day. So let's, if we... think if we start with a print push, then it becomes more consistent. JSON. Children. Okay, so we've done this. We really need to close it. So this is, yeah, this is one higher than we expect it to be, right? Let me step through this, I think. Yeah, this is stepping through. Print nodes. I'm sure there's some very obvious way of doing this, but I guess another option would be to like make an iterator for this, and then recurse through the things. Anyway. That JSON. Right, well that can't be right, can it? I guess surely this would make more sense towards the end rather than beginning, right? I say right, like I have any idea. I don't know. No, that's not true. Okay, so if we walk through it, right, okay, interesting. Okay, depth is 0 based, and this is effectively 1 based. As the, yeah, it's like how many curly braces do you have to go up? Okay. So you range. We go children. And then what was? Why is that wrong? Jason depth is 3. Alright. I'm gonna just do no depth plus 1 there. And then call it depth everywhere else. So we do children. Oh, okay, that's right. The JSON depth and the AST depth are not equivalent. Okay. Let's just keep a track of node star node p, previous one. Null to begin with. Or even just int depth p equals 0. Or, I mean, it's actually, it should be pretty straightforward. Node depth to JSON depth. Node. Depth equals node depth to JSON depth. So it's 1 plus. So there's 1 for the outermost for the root object, and then each object inside is it goes through a children, then into another object. I think it's 2. Alright, get rid of that though. Let's see, JSON. Sorry, JSON.0. Well, that got further, didn't it? Where did it break? Is that because my pop isn't right? I mean, there's actually quite a lot going on there that's apparently right. think it needs one more pop. Of the object, the outermost object. Alright, let's try to keep putting that into a file again. Oops. What just happened? We're pretty much there. It's just this final one, I think. Record decal. Field decal, field decal, field decal, record decal. I mean, I like that. Can you put comments in JSON? I can't even remember. I think not. Alright, the range thing is annoying. And how many is it off? Just 2, yeah. Okay, so we'll just make that a line. Isn't that a bit nicer? Okay, that's a bit less jagged. Let's do these to standard error. What happens if I don't do that? So I need to do that. That. Okay. Pop to 1, I think, is actually the answer. Yeah, load file. Yeah, and then oops, just lost my Twitch page. And then we do another print pop. That seemed harder than it probably should have been, but it seems to work. Handle pushing / popping children. Can just change the JSON set equals empty string. Yeah, so empty objects are now on one line. So on one line as range. I'm quite liking how this is looking, to be honest. I think when we hit 2, whenever we drop out of a child, I think we're gonna, might be a good idea to do that. Or just before each node, we could even Um, let's put that beforehand because I think that might be nicer with. I don't think it really matters that much. I think this is fine. It's pretty legible. Okay, I mean, this is looking pretty cool. There's a couple. We need to add types still. But as in a node per type, so that we can properly do the properly talk to each other. And we need to make the parent nodes give these their actual IDs. I might call this like node whip, node work in progress, and then change that to a node once it's an array of nodes once they're finished. Alright, let's have a quick look here. could make files their own node type. So we have, I think we have ints for in here? It just doesn't have any information attached to it. Right, I'm going to stop printing those IDs as numbers, as strings. Are going to be printed as numbers now. Just doesn't seem any point really. Wait, are you not allowed hexadecimal numbers in JSON? Is that why they've done this? JSON hexadecimal number. Must not have leading zeros. Oh man. Variables and other bases can be used unless they convert to base 10 first. Okay then. Wow. Alright, well I guess it is just a number, so let's convert it to number. Get rid of the not x at the beginning. Note, JSON disallows hex number literals. Yeah, let's go to depth P. JSON. Where does that get output? Alright, so look at main. .json. .ast. Oh, right, yeah. Doing puts, which goes to standard out. Cool. Nice. Nice, nice, nice. Okay. Awesome. Excuse me. Alright, I'm not going to do types now. Tag? Have I got tag for structs and that kind of thing? Let's just make sure that's getting printed. After name. Tag len greater than 0. String JSON tag node tag. Tag. Tag used. Tag used. I'm looking at the right thing, aren't I? I'm looking at the key. Should otherwise be name, yeah. Node dot tag equals val. Val is taken as a string. Okay. Tag is struct. Oh, was it already printed at that point? Ah. Right, I'm just gonna move that to here. No push there, and no push there. If we didn't hit an inner tag, push it before turning. Okay, and now we have tags. Cool. We don't need the return the result, as it doesn't have any children to be a parent to. Cool. Tag struct union. Wait, does this appear twice? Ah, I thought we were doing so well. '57 and '52. Oh, right, because we've pushed it again there. Okay. Node start node pointer equals null. Just make sure. I think that simplifies things. So union. Cool. That's better. We're not hitting it on the way out as well. Struct record decl data. Awesome. All right, I'm really happy with that. Let's save that. So what do we do? What did we change from last time? It's now git add up d to ignore that file. Yes for everything here. Commit message docs print as tree. Print JSON as tree. Captures all that's fine, that's close enough. Okie dokie, well, thank you very much for watching. If you're still here, then please check out WhiteBox at whitebox.systems, https://whitebox.systems. You can visit the chat room at chat.whitebox.systems, which is will just redirect you to Discord, to our Discord server. If you're particularly interested in WhiteBox, you can get access to the beta from the website. Be aware that there are still many bugs left to fix. I am going to continue working on this. I'm pretty happy with how it's going. I think we're going to work on types next time, and then after that we'll be working on actually using the output for something useful. But until then, thank you very much for watching, and I shall see you next time. Take care, everyone.